All right, today we're stepping into the operating room for a surgery that, on the surface, seems pretty routine, but it is anything but. This is a story where the standard procedures, the very things meant to keep a patient safe, could actually be deadly. So let's scrub in. And this is the absolute heart of the problem, right? How do you handle this? For this specific patient, putting him to sleep for surgery was basically like arming a bomb. The challenge wasn't just fixing a broken bone, it was surviving the anesthesia itself.
So, let's meet our patient. He's a 38-year-old guy with a fractured femur. I mean, that's a common injury, usually a straightforward surgery. But his medical chart, well, that tells a completely different story. See, he's living with two incredibly rare genetic conditions that turn the entire operating room into a minefield. These two conditions create a real perfect storm. On one hand, you've got hypokalemic periodic paralysis, which means if his potassium levels drop, he can become suddenly paralyzed. And on the other hand, there's Anderson-Towel syndrome, which makes his heart prone to chaotic, dangerous rhythms. So things that are common in surgery, like stress or a small drop in body temperature, could set off either of these right there on the operating table.
But wait, there was a third, hidden danger lurking in his DNA. One of his specific genetic mutations, a gene called CACNA1S, also put him at an extremely high risk for something called malignant hyperthermia. And this means the most common anesthetic gases could trigger a catastrophic full-body metabolic explosion. So the team was steering down three potential disasters: paralysis, cardiac arrest, and a hyperthermic crisis.
To navigate a minefield like this, there is zero room for error. The medical team couldn't just wing it. They needed a master plan, a pre-flight checklist that accounted for every single one of these risks. And that meant getting everyone involved.
And it was a true team effort. Neurology had to weigh in, stopping a specific medication that could cause problems with his genetic profile. Cardiology came in to reprogram his internal defibrillator so it wouldn't accidentally shock him during the procedure. And maybe most importantly, they set a very, very specific target for his electrolytes. Everything, and I mean everything, hinged on this one number: 4.2 millimoles per liter. That was the magic number for his potassium. If it went too low, he'd risk a paralysis attack. So for a full 48 hours before surgery, he was given oral potassium supplements to dial this in with absolute precision. This wasn't just a suggestion, it was a non-negotiable safety requirement. All right, so with the plan locked in, it was go time. Time to head into the OR. All that theory now had to become practice, where every single action was carefully choreographed to keep this patient safe.
Okay, so the first and most critical decision was the anesthetic itself. The standard gas anesthetics, completely off the table. They were the #1 trigger for malignant hyperthermia. The only safe way forward was something called TIVA, or total intravenous anesthesia. By using only IV drugs, they could bypass that single biggest threat.
And the precautions were just extensive. They controlled his environment meticulously. The room was warmed to 24 degrees Celsius, and a forced air blanket kept his body perfectly stable at 36.8 degrees. They kept him in a deep state of anesthesia to minimize any physical stress, and they checked his potassium from an arterial line every 30 minutes. And, just in case the worst happened, 36 vials of dantrolene, the only antidote for MH, were in the room ready to go. For 3 hours, everything went exactly according to plan. The team had controlled every variable, managed every risk. And then, an alarm shattered the calm of the operating room. Despite all that incredible preparation, the minefield had just been triggered.
I mean, just look at how fast this all went down. At 2:55 p.m., everything's fine. 5 minutes later, alarms are blaring. And the first sign wasn't a fever or anything obvious. It was a sudden, sharp spike in the carbon dioxide he was exhaling. 1 minute after that, his heart rate started to skyrocket. The crisis was unfolding right in front of their eyes. This was the first warning shot. His exhaled CO2, which is really a direct measure of his metabolism, shot up from a stable 48 to 62.
Now, this wasn't a breathing problem. This was a clear sign that his body's metabolic engine was suddenly revving into overdrive, just burning energy at a totally uncontrollable rate. And right on cue, his heart rate exploded from a steady 110 all the way up to 145 beats per minute. His heart was desperately trying to keep up with the metabolic chaos that was erupting inside his cells. This, right here, was the classic signature of malignant hyperthermia. And as if that wasn't enough, to make matters so much worse, at the exact same moment, his potassium level plummeted to 3.7, even though he was getting a continuous IV infusion. So now he was facing two simultaneous life-threatening emergencies, a full-blown malignant hyperthermia crisis and the looming threat of a paralytic attack.
This was the moment. This was what all that planning was for. The team didn't panic, they didn't have to guess what was happening. They had a protocol and they executed it instantly. No hesitation, just action.
Their response was immediate and three-pronged. First, they pushed 2.5 milligrams per kilogram of dantrolene, that MH antidote they had on standby. Second, they hit him with a rapid bolus of potassium to fight off that impending paralysis. And third, they started infusing cold saline to actively cool his body from the inside out. And because they were so prepared, their response was unbelievably effective. In just 10 minutes, the patient's carbon dioxide levels dropped, his heart rate settled back down, and the crisis was over. The plan had worked.
But the vigilance didn't stop there. After surgery, his potassium was stabilized within a day, and he regained full muscle strength before he went home. They did see a big spike in his creatine kinase. That's a marker for muscle breakdown from the MH event. But they managed it with aggressive hydration to protect his kidneys, and he made a complete recovery.
So what's the big takeaway from this incredible case? Well, it's a powerful story about how knowing a patient's genetic blueprint can fundamentally change how we practice medicine and really create a whole new standard for safety.
The bottom line is this. Knowing about that one gene, CACNA1S, was the key to everything. It's what flagged the risk of malignant hyperthermia and forced the team to create a custom plan. It dictated the choice of anesthetic, the temperature of the room, the need to have that antidote ready to go. It turned what could have been a fatal surgery into a manageable and ultimately a successful one. You know, this quote from the journal Anesthesiology just nails it. It's not about just reacting to problems as they pop up. It's about using genetic information to prevent them from ever happening in the first place, with a plan that's tailored to a patient's unique biology.
And this all brings us to a really fascinating final question. I mean, what we saw here was a highly specialized case, sure, but it points to a future where maybe a simple genetic test could become a routine part of a pre-surgical checklist for everyone, identifying hidden risks and creating a personalized blueprint for safety before a patient ever even enters the operating room.